Welcome guys to today's class. In this video, we want to discuss experiments on simple pendulum. Yes, it is important to note that one of the objectives of this experiment is to determine acceleration due to gravity. Yes, that acceleration due to gravity, you know in your elementary school that it is denoted as G equals to either 980 centimeter per second square or 9.8 meter per second square. This is the equivalent or the value of acceleration due to gravity in centimeter per second square or a meter per second square. So the essence of this experiment is to determine this. That means when you perform this experiment live and direct, what you should be getting should be close to this value. Yes, if it is not exactly this value, the answer you will get should fall in this range. G equals to 954 centimeter per second square to 1006 centimeter per second square. This is the equivalence. This is the range of value you are to get. That means if you approximate this to nearest whole number, it will give you 1000. That is, if you approximate this to nearest hundreds, unit tens, hundred. If you approximate it to the nearest 100, you get 1000. If you approximate this to the nearest 100, it will give you 1000. If you approximate this to the nearest 100, it will give you 1000. Then if you approximate this is a meter per second square. If you approximate it to the nearest whole number, it will be giving you 10 meter per second square. So this is the range of value of acceleration due to gravity, and this is the exact value we know from our elementary school. That means if I've done with performing experiment on this practical, or if I'm done with this experiment, what I should be getting should fall within this range. If you are talking about centimeter per second square. Then if you are talking about meter per second square, you are to get 9.54 meter per second square to 10.06 centimeter per second square, meter per second square. So you have seen that these are the range of value of your word G. So the answer you are to get should fall within this range. Okay? Now, what you do, or the essence of this video, is for us to see how to perform this experiment without touching apparatus. That is to say, we have to pick a value of G from this standard value we have, or range of values we have. Why I am considering this aspect is because the L given to us is in what? Centimeter. Now, this is the first time you got, the second time you got, the mean time, that is this plus this divided by 2, the period, which is this over number of oscillation, and square of this. Remember, when you are done with this experiment, I advise you, please include precaution taken to do this experiment to this extent. So don't forget to include precaution while reporting your results. Now, I'll pick a value here that is close to 980 and use it in getting my table. That is how we manipulate. We say G is equals to so what you have to do is to perform this without touching apparatus. What you do is pick a value from this range of value that is close to 980 and use it as your G. G is equal to I pick 970 centimeter per second square. Now this is the value I am to pick and use it with each of these values of L. Now my T is equal to 2 pi root what? L over what? G. Look at the value of or the formula for our G. This formula we knew it before now from our simple pendulum topic. So this is length and this acceleration due to gravity. With this formula, we will be getting the value for T and value for T squared. Now, to get our first period, we say 2 pi root, our L is 100, our G is 970. Then, to get your second period, you say 2 pi root 90 all over 970. To get your third period, you say this is 2 pi root 80 all over 970. Okay, let's get their values. These values, we put it here. Our first thing is 2.02. We don't attach the second to it because already it has second on this top. Then this is 1.91. So the third T is 1.80. Want to get the next one, that is one of 70. We will say 2 pi root 70 all over 970. Then the next one, 2 pi root 60 all over 970. Then the next one, 2 pi root 50. 2 pi root 50 all over 970. Let's get their value. Okay? So you get it with your calculator. Check the last one. So I succeeded to get all these values you are seeing here using calculator. That is T equal to 2 pi root L, which is each of these values will be taken as a L all over 970. And whatever I got, I just put it to be in 2 decimal places. I put it to be in 2 decimal places so that they will be uniform. I don't include seconds to it because already the heading is bearing second. Then after this, I have to get this value, and to get it, I will be squaring each of this value of T, which is 2.02 squared. That will be 4.0804, 1.91 squared, 3.65 seconds squared, 1.8 squared, 3.24 seconds squared, 1.69 squared, 2.86 seconds squared, 1.56 squared, 2.43 seconds squared, 1.43 squared. That is 2.04 seconds squared. So we have succeeded to get the values of T and values of T squared. Now, as we have gotten all these values, we want to see how to get this value. Recall that mean time all over number of oscillation is equal to period. Now note that the number of oscillation given is 20 oscillations. Therefore, mean time will be equal to number of oscillation times the period. 20 times each of the value of T. So 20 times 2.02 will give you 40.40. 20 times 1.91 will give you 38.2. 20 times 1.8 will give you 36, 33.8, 31.2. So when the 20 is multiplied to each and every of these values, you will get here. Now, when you are done with that, you also recall that to get your Tm, you say T1 plus T2 all over what? 2. The first value of T plus the second value of T all over 2. That will be giving you that 2 times this will be 2Tm equal to T1 plus T2. And that will be giving you that therefore T2 will be equal to 2Tm minus T1. T1 is taken to be Tm plus or minus 1.00 seconds. That means that this minus 1 will be 39.40. This minus 1, 37.20. This minus 1, 35.00. This minus 1, 32.80. This minus 1, 30.20. This minus 1, 27.60. Then next is T2 will be equal to 2Tm minus T1. 2 times 40.8, 2 times 40.4 minus 39.4. That should be giving us 41.40. Yes. Then 2 times this minus this, that should be giving us 39.20. 2 times this minus this, that should be giving us 37.00. 2 times this minus this, that should be giving us 34.80. 2 times this minus this, that should be giving us 32.20. 2 times this minus this, that should be giving us 29.60. Okay, so we have succeeded to get our table of values for this experiment. We want to see how to plot graph using this table of values we got from experiment on simple pendulum. Then afterwards, we want to see ways to find errors in the slope or intercept in a graph. Yes, that is very important. Now, this is just a typical what? Sketch. Just a sketch of how graph look like. But look at how standard graph is meant to look like. This is a standard graph sheet and it's measured in 2 cm. That is, this big box you are seeing is 2 cm. If you merge it, it becomes 4 cm. If you merge 3 of it, it becomes 6 cm. If you use only one, it becomes 2 cm. But if we are to use this graph sheet as it is on this board, you may not be able to see the spaces clearly. So we just have to use a sketch of the graph sheet so that we understand what we are doing very well. Now, to continue, first thing you have to do is write your date of the experiment. Date. Write the date. After writing the date, say a graph of, write the title, a graph of L, attach the unit against T squared, attach the unit. They are very important. After writing your date and the title, next thing is label your Cartesian axis. Label your Cartesian axis. How do we do that? To label it, remember they say plot a graph of L against T squared starting from origin and obtain the slope. Please, we have posted video on how to choose appropriate scale. I repeat, we have posted video on how to choose appropriate scale. Now, check our channel, just type Chidons Daniel how to choose appropriate scale during graph plotting. You'll see the video, then you watch it. Now, when we use the knowledge we've gotten from that video to sort this issue of number 1, plot a graph of L against T square starting from origin and obtain the slope. Let's see how to do it. Starting from origin, we are plotting L against T square. First thing you ask yourself is, for this L, the lowest is 50. Is it 0? I mean, is 50 close to 0? No. That means if you put 0 here, 10, 20, 30, 40, 50, look at where 50 will be falling. And this 50, 60, 70, 80, you now see that 100 will not enter. Yes, and here will be vacant because you not make use of here. Your graph plotting will start from 50 onwards. So you now see it's a poor way of plotting the graph. So what you will do is, since the lowest number is not close to 0, the lowest number here is not close to 0. Now, if I label my Cartesian axis to fall around here, this is my y own. That y, I will call it L in cm. Please, this L in cm, that is what you label, because what you are plotting is in cm. Don't write y against x. Please don't do that. Just label it appropriately. This is L in cm. Then this is t square. I will say t square is centimeter square. So don't say y against x. You have passed that level. Okay? Now, next thing to do is that instead of me writing 0, 0, if I write 0, 0, it will not be able to take care of these figures we have here because they are not close to 0. The lowest is not close to 0. What I will do is, I will put this symbol, a zigzag, then put this symbol. That means I am obeying the rule of starting from the origin, but I didn't write it because the lowest number is not close to 0. That is what this symbol means. So what I will now do is that I will now put 50. Maybe I want to start from 50 here. Here I want to start from 2. Yes. Then this now is, will I say 50, 55, 50, 60, 61, or will I say 50, 60? How will I label the scale? To label the scale for the L, I will say the highest, which is 100, minus 50 all over, how many buses do we have? 1, 2, 3, 4, 5, 6, all over 6. That should be giving me 50 over 6. 50 over 6 is 8.3. Now, this 8.3, we will approximate it to nearest tens. How do we do that? 8.3 is something as 0.8.3. Nearest 10 means this is units and this is tens. Nearest tens. Is this up to 5? Call it 1. Because it is up to 5, add it to this, it will become 1. Then we have 2 digits before the decimal point. So we make here to be 2 digits before the decimal point. So this is approximately to be what? 10 centimeters. Then that means we are using it to nearest 10 so that you can easily locate these points we are seeing here. Then this one approximately, this is 0.3 if you approximate it. But if you are using 0.3, 2.3, 2.3, 2.6, there are figures it will not be able to accommodate. We say let us approximate it to 0.4. So 0.4, that will give you that 2 plus 0.4, 2.4, 2.8, 3.2, 3.6, 4.0 and 4.4. Whereas here it should be 60, 50 plus 10, 70, 80, 90, 100. So we have taken our scale. We'll also do it here likewise, because we want to duplicate it. So we say put this, then this is 2, 2.4, 2.8, 3.2, 3.6, 4.0 and 4.4. And this is 50, 60, 70, 80, 90, 100. This is L in cm and this is T in second squared. Now let's locate their points. Hundred against 4.08. 100 against 4.0. This is 4.0, so 4.08 will be around here. 90 against 3.65. 3.65 will be around here. Then 80 against 3.2. 3.24 around here. 70 against 2.86 around here. 60 against okay, so we have succeeded to plot this graph, then duplicate it, put our line of best fit. Now recall you have to write the title here, a graph of L in centimeter against T squared, that is a second squared. Then put your date. So next thing we have to do is, let's see how to get our slope. See how we get it. Now you say change in L and change in T squared. Please note that the values we are using or we are getting from this is an approximated value because we are using a sketch of the graph. Now this is 100. This is 100. 100 minus, then this is 50, this is 50, because this is the highest value, we call it our L2, minus the lowest value, 50. Then that is for change in vertical on. Then for horizontal, where the vertical and horizontal meet, that will give you your T squared 2, that is the highest T squared. So what is our highest T square? Our highest T square, this is 4.0. So we'll take here to be 4.1, approximately 4.1. We say here is 4.1 minus, then here our T square 1, that is approximately 2.1, because here is 2.0, so it's approximately 2.1. So what we now do is, we now say this minus this, slope equals 100 minus 50, 50, all over this minus this, 2.0. Recall, highest 100, lowest 50, here about 4.1, and here about 2.1, that is 2.0. So approximately to nearest whole number is 2.1, or to nearest decimal is 2.1. So you now have 4.1 minus 2.1 equal to this. But when you use your graph sheet, I mean your standard graph sheet to plot it, you get the accurate value. This minus this divided by this will be giving you 25 centimeter over second square. It's important to attach the unit of what you got. I got my own by saying 25. What is vertical unit? Unit for the vertical is cm. Unit for horizontal second square. So that is your answer. Now, get your G from this. Recall we plotted G equals to, the experiment has a formula which goes this way, all over G. From here, we modify it to say that this means t squared equal to 2 pi enter inside 4 pi square L over G. This is equivalent to this. Then we say that this means if we carry G up and carry t squared down, we have G equal to 4 pi square L over t squared. And L over t squared is what we plotted. L over t squared, that is what we plotted. So whatever we get here will be called our slope. That means our G is 4 pi squared times slope. G equals to 4 pi squared times slope. And what is our slope? Slope is 25. So we will press it inside our calculator. This will be giving you approximately 987 centimeter per second square. Recall we used initially G equal to 970 in the experiment. In the start of the experiment, we got G equals to 900. Recall that in the start of the experiment, we say let's take our G to be 970 centimeter per second square. Yes, but after solving or after doing the experiment, we have 987 centimeter per second square. The reason why we didn't get the exact value is because approximations were done in this experiment. But this answer we got, the question is, did it fall in the range of value we noted? We say range of value is 954 to what? 1006 centimeter per second square. This is the possible range of value. So 987 still fall in the range of value. So we are still correct. So we have seen how to get the slope and the value of G. Next is to get the error in the word slope. Error in the slope. Let's see how to get it. And we want to see how to get it in two different ways. Now, to get errors in this slope, we want to follow the first method and see how we can use the first method and get the error in this slope. That is the method of best fit and worst fit. Before we see how to make use of best fit and worst fit, it is important to note that the line of best fit is meant to pass through the mean of the vertical points plotted, the mean of the vertical points plotted, and the mean of the horizontal points plotted. See what I mean? For mean of L, L mean is equals to, add up the values of L, 100 plus 90 plus 80 plus 70 plus 60 plus 50, all over 6. 100 plus 90 plus 80 plus 70 plus 60 plus 50 divided by 6. 1, 2, 3, 4, 5, 6. divided by 6. That will be giving us 75, equal to 75. Now we are to get the mean of t squared. Mean of t squared is 4.08 plus 3.65 plus 3.24 plus 2.86 plus 2.43 plus 2.04 all over 6. T squared, the mean of t squared, everything divided by 6 is 3.05. So the mean of the length is 75. The mean of t squared is 3.05. What you now do is locate 75. This is 75. 3.05. This is 8. So look at where they meet. So look at where they meet. That means this point that fell off, what you do is that point, this point have to pass through that mean. That mean you have. You have to draw another line of best fit to pass through that mean. Okay? So this second line of best fit, we call it worst fit. Then this one we call it best fit. This is best fit. Then this is worst fit. We'll call this line of best fit. That is the first one we drew. We'll call the second one line of worst fit. By taking, if it is only one point that fall off or fall out, you take that one point. Look at the 1 point. You take that 1 point and make sure it pass through the what mean of the vertical and horizontal, their mean value. It will pass through it. So this line will pass through it, the way the other one pass through it. That is very important because any line or regression line you draw should pass through the mean of vertical and horizontal. Then what you now do is that you get the slope of that line. Okay, so after putting the line of worst fit, then what you do, we will put our triangle. We'll put it. This is the triangle for line of worst fit, whereas the other one is line of best fit. What we now do is, what is the highest value here? Approximately 100 minus what is the lowest value? That is 60. That will be giving you 100 minus slope equals to 100 minus 60 is 40. Then you come here. What is the highest here? This is change in t squared. The highest is 4.0 minus what is the lowest here? This is 2.4, so here should be around 2.5. 4 minus 2.5. So 40 over 4 minus 2.5 is 1.5. 40 over 1.5, that should be giving us 26.7 approximately. 26.7. This is the slope for worst fit. Slope for line of worst fit. WF means worst fit. Now error in slope is equals to modulus of slope for best fit minus slope for worst fit. Modulus means whenever you minus, if you give a negative, forget about negative. We have the normal slope, which is for the line of best fit to be 25. So error will be equal to 25 minus 26.7 modulus of 8. 25 minus 26.7 will give you 1.7 minus 1.7. But modulus means forget about the minus. So 1.7 centimeter per second square. That is the error in that slope. Error in the slope was gotten to be 1.7. You now see your slope is equals to 25.00 plus or minus 1.7 bracket cm per second square. Now, to get the error of the slope, we have only one point that fall out. So what we do is we take that one point and draw a parallel line, a line that will be parallel to the line of best fit. When we are done with the drawing, we take a vertical line. Look at a vertical line between that parallel line and line of best fit. We locate the highest point of that vertical line. You can take the vertical line at any point. You can take it here, you can take it any point. So look at here. This is how to get your vertical scatter. You say error in the slope, error equals to 4W all over NR, where W is your vertical scatter, R is the range, that is the highest value minus the lowest value, which is R equals to 4.08 minus 2.04, that is 2.04. And how many points do we have? 6. W is equal to 90 minus 85, that should be 5. Therefore, error is 4 times W, 5, all over 6 times 2.04. Let's see what it gives us. So 4 times 5 is 20, all over 6 times 2.04, that should be giving you 1.63 centimeter per second squared. So what we have is, we package it this way: slope equals to 25.00 plus or minus 1.63 centimeter per second square. This value is using this method, that is error in the slope equals to 4 times vertical scatter all over NR.